when I try to find the centroid of this area, what I usually do is that I put uh, my rectangle parallel to the x-axis, since I'm looking for the centroid of the shaded area. So I'm putting it parallel to the x-axis. So I have something like this. So this distance right here, I don't know what it is. So it is, we just call it dx. Sorry, this is dy. And then here, this length from here to there is x. So we start by writing the equation for our area for that rectangle over there. So we have dA is equal to x, multiply that by dy. So we already have the equation for the graph. So we have y is equal to 1 over 4 x squared. So we have to get rid of that x over there, and we have to write this equation in terms of y. So we have 4y, multiply both sides by 4, and then we have x squared. And then we take the square root of both sides, and then we have x. And then now we take this x, we plug it into our area equation. So we have the square root of 4y, multiply that by dy. So that's the area for that rectangle. Now we have to find this centroid of that area. So we have this area. Let me enlarge it right here. So we have this area, we have dx, and we also have x over here. So the centroid of this area is somewhere around there. So centroid of that area is equal to x divided by 2, which means that x, I erased it, so we have x is equal to the square root of 4y. So that centroid, or the moment arm, is equal to the square root of 4y divided by 2. Now we have everything that we ever wanted. So now we can find the centroid of the shaded area. So we're going to have x is equal to the integral from 0 to 4. So we have 0 to 4, multiply that by the x, that moment arm, multiply that by d8, all divided by the integral from 0 to 4 dA. So now we have the integral from 0 to 4, multiply that by, sorry, we have, okay, 4, 2, multiply that by dA, which is square root of 4y dy. And all of that is, we divided by the integral of the area, which is the square root of 4y dy. Now to save time, you can just plug this into your calculator and you should get the value of 1.5 meters, and this is your final answer.